In 1957, a telescope in Mexico photographed a star that didn't exist. Not a fake, not a glitch, something worse. A point of light so ordinary looking that two astronomers filed it away as entry number 618 in a catalog of faint blue stars and moved on to the next plate. No fanfare, no warning, just a number in a ledger, sitting next to hundreds of other numbers that meant nothing. For 13 years, that's all it was. A boring dot, a rounding error in a survey of the sky. The kind of object that exists purely so astronomers have a reference point when they're measuring something more interesting nearby. But it wasn't a star. It was a monster wearing a disguise. And when astronomers finally saw through it, they found something that still, decades later, doesn't fully make sense. A black hole so massive that if you dropped our entire solar system into it, the Sun, Mercury, Venus, Earth, all the way out past Pluto, there would be room left over, and still more room after that. A black hole so bright that if you moved it to the center of our galaxy, it would erase the night sky and outshine the moon by more than 20 times. A black hole so old and so impossibly overgrown for its age that it breaks the timeline we use to explain how black holes are even born in the first place. This is the story of TON 618, not just what it is, but how something this violent hid in plain sight for over a decade, why it still doesn't fit our models of the early universe, and what it's quietly hiding from us even now. Before we begin, if you're curious about the universe and the incredible stories hidden within it, consider liking the video and subscribing. Every bit of support helps us bring more fascinating discoveries to curious minds around the world. Now, let's begin. Every monster needs an origin, and this one starts with two men squinting at photographic plates in the mountains of Puebla, Mexico. The year is 1957. The Tonantzintla Observatory is running a survey. Not hunting monsters, just cataloging faint blue stars, the kind astronomers use as reference points for calibrating other observations. It's meticulous, unglamorous work. Braulio Iriarte and Enrique Chavira process plate after plate, night after night, and most of what they find is forgettable. Small, dim, distant white dwarfs, stellar background noise, the wallpaper of the night sky. Then they log object number 618, a faint, decidedly violet point of light, barely distinguishable from the dozens of similar dots around it. Nothing about it screams for attention. It gets a name, TON 618, short for Tonantzintla 618, and it gets filed. Nobody circles it. Nobody flags it for follow-up. It's just another entry in a long, patient list. Here's the part that should unsettle you. Quasars weren't even a recognized category of object yet. The word quasar wouldn't be coined until 1963, 6 years later. So when TON 618 first appeared in the records, there was no framework it could have been slotted into. No alarm bell that could have gone off even if someone had looked closer. Nobody could have known what they were looking at. The disguise wasn't clever. It was simply that the costume department of the universe hadn't been invented yet. For 13 years, TON 618 stayed a star, correctly cataloged and completely misunderstood. For 13 years, nobody had a reason to look twice. Astronomical surveys generate thousands of these faint entries, and the whole point of cataloging them is to move quickly, not to dwell. TON 618 wasn't unusual enough on a photographic plate to justify a second glance. It looked exactly like the background noise it was supposed to be filed as. That's the quiet horror of it. Not that the discovery took 13 years, but that there was nothing in the original data that demanded it take any less time. The disguise wasn't a trick played on careless observers. It was a genuine limitation of what a single photograph, taken with 1950s technology, could ever hope to reveal. Then, in 1970, everything changed with a single unglamorous observation. A radio survey conducted in Bologna, Italy, pointed its instruments at that same patch of sky and picked something up. Static. Radio noise, pouring out of a star that shouldn't be making any noise at all. Ordinary stars are radio quiet. They don't shout across the electromagnetic spectrum. Whatever this was, it was screaming in a frequency nobody had thought to listen for. That discovery sent astronomer Marie-Hélène Ulrich to the McDonald Observatory in Texas, where she pointed a spectrograph at TON 618 and finally got an answer written in light itself. The spectrum wasn't starlight. It carried emission lines stretched and shifted by redshift. The unmistakable fingerprint of an object so far away that its light had to fight billions of years just to reach us. TON 618 wasn't a star 30 light-years from Earth. It was a beacon roughly 18 billion light-years away, and it was so overwhelmingly bright that even across that mind-erasing gulf of space, it was still visible from telescopes in our own backyard. 13 years of disguise, dismantled by a single spectrum. The faint blue star was gone. In its place stood one of the most luminous, most violent objects the universe has ever produced. And astronomers were only just beginning to grasp how violent. So what actually is TON 618? Not a black hole floating alone in empty space, a quasar, the blazing overactive nucleus of a galaxy, powered by a supermassive black hole, feeding on everything unlucky enough to drift too close. Gas and dust spiral inward in what's called an accretion disk, whipped up to velocities close to the speed of light by the black hole's gravity. Collisions and friction inside that disk generate temperatures in the tens of thousands of degrees, and the disk radiates across nearly the entire electromagnetic spectrum, from harmless radio waves all the way up to lethal X-rays and gamma rays. The result is a light source so overwhelming, it drowns out the light of every star in its host galaxy combined. We can't even see TON 618's actual galaxy. The quasar at its center is too bright. It's like trying to spot a candle flame held directly in front of a floodlight. The candle is still there, still burning, but you'll never see it. Meanwhile, somewhere in that same churning storm of matter, magnetic fields twist, coil, and snap under unimaginable pressure, launching colossal jets of plasma out from the black hole's poles at velocities approaching the speed of light. These jets don't just flare briefly and fade. They stretch for millions of light years, longer than entire galaxies laid end to end, carrying enough raw energy to physically reshape the galaxy they erupt from, blowing gas out of the galaxy entirely, starving future star formation, and altering the course of that galaxy's evolution for the rest of its existence. A single object at a single point in space, rewriting the fate of everything gravitationally bound to it. And bright undersells what's actually happening. TON 618 shines with the output of roughly 140 trillion suns, not stars. Suns, all of them exactly like ours, all of that light originating from a single point. If you swapped TON 618 in for the black hole at the center of the Milky Way, its glow would be more than 20 times brighter than a full moon, and it would wash out every constellation you've ever learned to recognize. The night sky as a concept would simply stop existing. There would be no darkness left to see stars against. But the light is only half the story, and arguably the less terrifying half. Buried at the center of that light is the actual monster, a black hole with a mass estimated in the most widely cited studies at around 66 billion times the mass of our sun. Even the more conservative modern estimate, which uses a different spectral line, the C4 line instead of H-beta, and arrives at a lower relative velocity for the surrounding gas, still lands at roughly 40.7 billion solar masses. Lower, but not remotely small. Either number describes something almost impossible to hold in your head. For comparison, the black hole at the center of our own Milky Way, Sagittarius A star, weighs about 4.3 million suns. respectable by black hole standards. TON 618 outweighs it by a factor of more than 15,000. This isn't a bigger version of our galaxy's black hole. It's a different category of object entirely. One so extreme that scientists have proposed an entirely new classification just to contain it. Ultramassive black holes, a tier above supermassive, reserved for objects that break the usual scaling rules. Zoom out to the broader family of monster black holes NASA has directly measured, and TON 618 still sits alone at the far end of the scale. There's a dwarf galaxy hosting a black hole of just 100,000 solar masses, so compact its shadow is smaller than our Sun. There's the pair inside galaxy NGC 7727, two black holes of 6,150,000,000 solar masses, spiraling toward a merger that will finish in roughly 250 million years. There's M87, with its 5.4 billion solar mass giant. And then there's TON 618, sitting at the very top of that entire lineup, boasting a shadow so large that a beam of light would need weeks, not days, to cross from one edge to the other. To put a number on the emptiness at its center, a black hole of this mass has a Schwarzschild radius, the radius of its event horizon, of roughly 1,300 astronomical units, or about 194 billion kilometers. That's more than 60 times the distance from the Sun to Pluto. Using the lower, more recent mass estimate, the event horizon shrinks to around 800 astronomical units, still 40 times the Sun-Pluto distance. Either way, our entire solar system could be dropped into that darkness and simply disappear, with room left over on all sides. Here's where the real problem creeps in, though. And it's not about size at all. It's about time. TON 618's light has been traveling toward us for roughly 10.8 billion years, based on its redshift. That means we're not looking at TON 618 as it exists today. We're looking at a snapshot of it as it was when the universe was barely a quarter of its current age. Galaxies were still assembling out of gas and gravity. The first generations of stars had only just lit up a universe that had spent its early existence in total darkness. And somehow, in that narrow, chaotic window of cosmic history, a black hole had already ballooned to 60+ billion solar masses. That shouldn't be possible. Or, at the very least, it shouldn't have been easy. Every black hole is thought to start small, relatively speaking. A stellar remnant, left behind when a massive star runs out of fuel and collapses under its own gravity. Or, in some models, the direct collapse of an enormous cloud of primordial gas, skipping the star phase entirely and forming a black hole seed thousands of times more massive than the Sun right from the start. From either starting point, growth is supposed to be gradual. Consume nearby gas. Swallow the occasional unlucky star. Merge with other black holes when galaxies collide and their cores eventually spiral together. Repeat this process patiently for billions of years, and you eventually end up with something supermassive. TON 618 didn't have billions of years to work with. It had, at most, a few. And instead of ending up merely supermassive, like Sagittarius A star or the black hole at the heart of M87, it ended up ultramassive. In a fraction of the time the standard model of black hole growth allows for. For a sense of scale on just how far ahead of schedule TON 618 is. M87's central black hole, the one famously photographed by the Event Horizon Telescope, weighs in at around 5.4 billion solar masses. Itself a genuine giant, with a shadow so large that a beam of light would need roughly 2.5 days just to cross it. TON 618 outweighs even that by more than a factor of 10, and it did so while the universe was still in its cosmic infancy, billions of years before M87 had fully assembled. Whatever process built, TON 618 wasn't just fast, it was fast in a universe that, by every other measure, should have still been getting started. So, astronomers were left with a choice: and neither option was comfortable. Either the physics of early black hole growth needed serious revision, or TON 618 was born already enormous, seeded not by an ordinary collapsing star, but by something far more extreme in the infant universe. Perhaps a direct collapse of gas clouds far larger than anything we see forming stars today. Perhaps feeding conditions in the young cosmos were simply more violent, more chaotic, and more generous with fuel than anything happening in the universe now, allowing early black holes to gorge themselves at rates we don't see replicated anywhere in the modern sky. Neither explanation is fully satisfying. Both require rewriting assumptions that have held up reasonably well everywhere else we've tested them. And TON 618 doesn't care which explanation you find more palatable. It just sits there, enormous and 18 billion light-years away, daring the math to catch up to it. There's a third possibility too, one astronomers can't fully rule out, that TON 618 simply isn't unique, and we've only found it because it's bright enough to see across such staggering distances. Smaller, quieter monsters of similar age might exist by the thousands, hidden simply because they aren't feeding aggressively enough to light up the way TON 618 does. If that's true, the real puzzle isn't TON 618 itself. It's how many other impossible objects are sitting out there right now, simply too dim for our current instruments to notice. This is the moment where TON 618 stops being just a spectacular object to marvel at and starts being a genuine problem the entire field of astrophysics has to reckon with. A single stubborn data point that refuses to fit the model, forcing everyone to ask an uncomfortable question. What if the early universe was capable of growing monsters far faster than we ever imagined it could? Now picture standing near it. Not physically possible, obviously. The radiation alone would end you long before gravity got the chance. But let's break the rules of survival for a moment, because this is where the story earns its terror. The event horizon of TON 618 spans somewhere between 800 and 1,300 astronomical units across, depending on which mass estimate you trust. Even on the smaller end, that's roughly 40 times the distance between the Sun and Pluto. On the larger end, it's over 60 times that distance. Our entire solar system, planets and all, would fit inside that darkness with enormous amounts of space left over. As you approached, the sky itself would start to lie to you. Light from behind the black hole would bend around its immense gravity and curve back toward your eyes, wrapping the darkness in a faint glowing halo, photons trapped in unstable orbit, circling the abyss again and again, before finally spiraling inward and vanishing. And the colors would betray you too. Radiation near the horizon gets gravitationally redshifted, stretched into longer, dimmer wavelengths as it fights to climb out of that gravity well. To your eyes, once bright light would fade into a deep, bleeding crimson, as if the black hole were slowly draining color out of the universe itself, one photon at a time. Then there's time, which stops behaving the way you expect it to. Get close enough, and every second you experience would stretch into years for anyone watching from a safe distance. To them, you would appear to freeze in place, trapped at the very edge, never quite falling in, never quite escaping, suspended forever at the boundary of eternity. Not because you had stopped moving, because gravity had stopped time from agreeing with itself between your reference frame and theirs. And that's all before you even reach the horizon. Cross it, and there is no coming back to describe what waits beyond. Somewhere past that boundary lies a singularity, a point where density becomes infinite, and the physics we rely on for literally everything else in the universe simply stops working. Not a mystery we simply haven't solved yet. A wall we don't yet have the tools to see past. A place where our equations quietly hand in their resignation. And the black hole itself isn't even eternal. Strange as that sounds for something this large. Current models suggest TON 618 will persist for roughly 1.3 times 10 to the 99th power years. A number so large it stops meaning anything intuitive, slowly bleeding away mass through Hawking radiation, until it finally evaporates near the very end of what cosmologists call the black hole era. A stretch of cosmic time so distant that the universe will, by then, be almost 100 orders of magnitude older than it is right now. Everything about TON 618 operates on a timescale built to make human time feel like an illusion. This is what a 13-year-old faint blue star turned out to be, once someone finally looked closely enough. But TON 618 isn't only a destroyer. It's also, strangely, a gift to the rest of us studying the universe from a very safe distance. Because it's so extraordinarily bright, TON 618's light doesn't just travel to us in a straight, empty line. It passes through nearly the entire observable universe on the way here, cutting straight through vast clouds of intergalactic gas that would otherwise remain completely invisible to our instruments. By analyzing exactly how that gas absorbs and alters TON 618's light on its long journey, astronomers can effectively map the chemistry of the early cosmos. They can trace where matter first began to cluster together, study how galaxies grew and changed shape in the first billion years after the Big Bang, and reconstruct a version of cosmic history that would otherwise be lost to us, hidden behind billions of years of empty-looking darkness. And in 2021, radio telescopes in Chile's Atacama Large Millimeter Array found something else, wrapped around TON 618 like a shroud. An enormous cloud of gas, at least 330,000 light-years across, more than 3 times the width of our entire Milky Way galaxy, glowing brightly in a specific wavelength of ultraviolet light called Lyman alpha radiation. It's classified as a Lyman alpha blob, one of the largest structures of its kind ever directly observed, and it holds roughly 50 billion solar masses of material in its inner region alone, with an equally massive outer envelope of cold gas surrounding it. Both components align precisely with the relativistic jets blasting outward from the black hole's poles, as if the entire structure has been sculpted by the very monster sitting at its center. TON 618 isn't just eating its surroundings. It's lighting them up like a lantern hung in the darkest room imaginable, letting us glimpse cosmic structures that would otherwise sit invisible and unstudied. Destroyer and window somehow, in the exact same object. A monster bright enough to help us study the very universe it terrifies. Here's what stays with me about TON 618, long after the numbers stop being impressive and start being genuinely unsettling. It's not just the size. Even though the size is genuinely hard to hold in your mind for more than a few seconds at a time, it's the disguise. For 13 full years, the single most extreme object we had ever recorded sat quietly in a catalog, misfiled as a boring, unremarkable star, simply because nobody yet had a category for what it actually was. The problem was never in the data. Iriarte and Chavira recorded it correctly, exactly as it appeared through their telescope, with careful, honest observation. The problem was that the universe hadn't handed us the right question to ask of it yet. That's a strange, quietly humbling thing to sit with. Some of the most violent, most consequential objects in existence might already be sitting in our records at this very moment, correctly observed, patiently waiting, filed under the wrong name simply because we haven't asked the right question of them yet. TON 618 didn't change the moment astronomers finally figured it out in 1970. It had already been a monster of 60+ billion solar masses the entire time, quietly burning at the edge of the observable universe. What changed wasn't the object. What changed was us. There's also a strange comfort buried in that same fact, if you look at it from the other direction. The universe isn't secretive by design. It doesn't hide its monsters out of malice or mystery for mystery's sake. It simply hands us data, honestly and without editorializing, and waits for us to build the right framework to interpret it. Iriarte and Chavira weren't wrong. They just hadn't been given the word quasar yet. Sometimes the biggest discoveries aren't about looking harder. They're about waiting for the right question to finally exist. If a story like this could hide in plain sight for 13 years, imagine what else is still waiting to be found. That's exactly what we dig into every week on Big Data Vault. And even now, more than half a century after that discovery, TON 618 keeps forcing the same question forward, refusing to let anyone settle into comfortable certainty. How do black holes grow that fast, that early in cosmic history? What does it mean that the young universe was apparently capable of building monsters faster than our models say it should have been able to? We don't fully know yet, and the honest answer might require rewriting parts of the story we thought we already understood. Which means somewhere out there, right now, drifting quietly through another decades-old survey, there might be another TON 618, another impossible thing hiding in the open, filed as something forgettable, patiently waiting for someone to look again. So here's where we end up, exactly where this story started. Somewhere in the constellations Canes Venatici and Coma Berenices, there is still, technically, an entry in an old catalog that reads Faint Blue Star, number 618. It was never a star. For 13 years, the single most terrifying object we know of hid behind the disguise of an ordinary one. And it's still out there right now, 18 billion light years away, quietly rewriting everything we thought we understood about how monsters are born.